So now let's go to the next event when vehicle has gone from 15 kmph to 33 kmph in 10 seconds. What is that event? Is here. So from 15 kmph to 33 kmph in just 10 seconds. So we will calculate watt hour per kilometer for this. So just come to this sheet and we will write from 15 kmph to 33 kmph in, and I'm going to use goal-seek method, but and if you see here it is error value, you got it. And if you use goal-seek at this point, then goal-seek will not going to calculate this value. So I'm just going to change the torque randomly to get some number here, and I got it. Now I'm going to use goal-seek method and I'm going to put the value 10 while changing this torque value, and we got it, which is 24.95. And for this, what is watt hour per kilometer? 268.34. So we'll copy this value and then we'll paste it here. What is the distance that we got it? 66.9. We'll copy this value and then I will paste it here, and we'll got the energy consumption during this event. Now let's go to the next event when the vehicle is now again decelerating from 33 kmph to 20 kmph in 10 seconds. And again here we are going to consider vehicle is going from 20 kmph to 33 kmph in 10 seconds. We will calculate the watt hour per kilometer, but the sign here I am going to put the negative. So let's come back to this sheet. So final velocity is 33 and the V1 is now 20 kmph. So let's put this value 20 kmph. And what is the time now required? 10 seconds. So let's take the help of goal-seek, put the time 10 while changing this torque. So we got the torque 19.9 and the watt hour per kilometer that we have is 214. And let's copy this value and put here, but instead of positive value I'm going to use negative value here. And what is the distance covered during this event is this one. So come here and then paste this value, and what is the energy went back to the battery is 15 watt hour. Now let's go to the next event when vehicle is going from 20 kmph to 42 kmph in 38 seconds. So let's go to this sheet here and now put this the final speed, which is how much? 42 kmph. So I will put this 42 kmph. Now what is the time required for this? Is 38 seconds. So we will use the goal-seek method and we will put 38 seconds while changing this torque. We got the watt hour per kilometer, which is 137. Let's copy this value, put here, and what is the distance? We got 332.81. Let's copy this value and paste it here and just drag it here. So during this event the energy consumed from the battery is 45.85 watt hour. Now again the next event is again decelerating, and in this case also now energy flowing from motor to battery, but here again we are going to assume that the vehicle is going from 0 to 42 kmph in 18 seconds. We will calculate the watt hour per kilometer and just we will put the negative sign. So let's come to this sheet, which is fun with vehicle dynamics, and then let's put here 0, and what is the time required? Now time required is 18 seconds. So let's come here and then use our friend goal-seek, put the time 18 seconds by changing this torque, and we got the watt hour per kilometer 327. We will copy this, we will paste it here, but instead of positive I will use negative sign. The next thing what I am going to do, find the distance, which is this one. I will copy this value and I will paste it here, and this I will just drag it. So in this case the energy has flown from motor to battery, and the amount of energy is 34.95 watt hour. So with this we have calculated the energy consumption for each and every event.